Okay, so who can tell me what it means to combine like terms? Or what a like term is? What does it mean in algebra if something is considered like terms?
They're alike.
They're similar, but how are they similar? What do they have in common? The same what?
Terms.
Okay, but what about those terms makes them similar or considered like? They have to have the same. Starts with a V.
Variable.
Variable, thank you. Yes, they must have the same variable and or exponent, but we're not going to be talking about any of these that have exponents. So they either have to have the same variable and you can combine them, or they just have to be two numbers that don't have variables. So like I can combine 3x and 4x. What would I get if I combined 3x and 4x?
7x.
7x. And I combine negative 12 and 7. What would I get if I combined negative 12 and 7?
5. No, negative 5.
Negative 5, right? So we use the word combine because we're not necessarily always adding or always subtracting. We're just trying to simplify them and make them into one term instead of having 2 or 3 separate terms. Okay. So our notes today are going to be, let's see here, let me get this straight out. Okay, Kyson, enough with the comments and the captions and what have yous. Okay, so it is Monday, October 26th. Wow. And we're doing combining like terms. And distributive property. Okay, so who can tell me what the distributive property looks like? What do you usually have when you're using the distributive property? What's your signal? Like, hey, I need to distribute. Okay, picture it in your mind. When I distribute, I use multiplication. So what symbols do we use to show multiplication? Who can tell me some symbols that we have there? You can use an X, right? When you were like in elementary school, you used the X for multiplication. What else can you use for multiplication? A little dot, right? And then there's one other way to show that you're going to multiply these values.
Is it like right by like a number or something like that?
And yes, okay, so a letter next to a number is multiplying. And okay, I lied. There's another way to show it. Kyson?
A close thing?
Parentheses, right? Okay, so we're going to focus on the parentheses today when we're combining like terms and using the distributive property. So let's go ahead and start out with combining like terms. So we're just going to solve a few equations where we are combining like terms. So now we have, these are multi-step because it's not just two-steppers. We have a couple things we need to do here, a few things. So we have 8x minus 6x minus 25 equals negative 35. Okay. I'm still going to do my wall of equality. I'm still going to draw that. Remember, if you cross that wall, you have to use inverse operations. Do you see any like terms? Do you see any terms that have the same variable? The coefficient doesn't have to match, but they just have to have the same variable. Agree? Right. So I see that 8x and 6x can be combined. I'm going to put a circle around these. What is 8x minus 6x? How many x's do I have left? Kyson? 2. So now I've got 2x minus 25 equals negative 35. And now I have a two-stepper, right? You're always going to get to that two-step moment. So then what's my first step of my two-stepper? What am I going to do?
Adding 25.
I'm going to add 25 to both sides because now I'm going across my wall of equality. So I'm going to have 2x equals negative 10. Right? because it's negative 35 plus the 25. And then what's my last step? What am I going to do, Bree? Divide by 2 on both sides. So now I've got x equals negative 5. So we're still using those skills from before break, our inverse operations. We're just now adding a layer on with combining like terms. Okay. Let's try another one. Got negative 4n minus 8n plus 17 equals 23. So I'm going to draw my wall of equality. Savannah, what are my like terms for this equation? Great. So I'm going to circle those, and I'm going to say, all right, I'm going to combine these. So what is negative 4n minus 8n? What's it going to be? I'll give you a hint. It's still negative.
Negative 12.
Negative 12n plus the 17 equals 23. And now I've got my two-stepper. We love our two-steppers. So I'm going to subtract 17 from both sides. I'm left with negative 12n equals 6. Divide both sides by negative 12. And I'm going to have n equals negative 1/2. I'm pretty sure we talked before break about always putting the negative with the numerator. It just looks better. It's more organized. However, if you put it somewhere else, I'm not going to count it wrong. Right? It's still equivalent. I just think this will help you in the long run when you get to super complex equations. Okay, one more. Can you guys fit another one on your paper?
Yeah.
If you can't, it's okay if you need to go to another paper. 3x plus 7 minus 3 plus 10x equals 43. All right, I've got a couple pairs of like terms here. Who can tell me one set of like terms? Kyson?
3x and 10x.
All right, so I'm going to circle those, 3x, and I'm going to circle the plus 10x, because the symbol in front tells you how you're going to combine them. So how many x's do I have now? 13x. Oh, you guys, I forgot my wall of equality. So now I've got 13x, and then what can I do with that 7 and the positive 7 and minus 3? I can combine them, right? So if I have to combine, I'm going to use a square here so you guys can see like my terms with my variables or the circled ones, and then I put a square around this one. So what is positive 7 minus 3? Positive 4. So I bring down plus 4, and I also, of course, bring down the 43. I'm going to rewrite this. That 13 looks weird. And now I have a two-stepper. See? All right, so I'm going to subtract the 4 from both sides. Bring down the 13x equals 39. Divide by 13. X equals 3. Oops, that doesn't look good. Hold on. I don't know what is going on with the lighting here. Let me try this. That's a little better. Any questions about combining like terms before we move on to distributive property? Okay. Let's see, what page were we on? This should be page 25. Does that seem right for you guys? So now I'm going to be on page 26, and we're going to do distributive property. 2, and then the way we say this right here, what's happening is we say 2 times the quantity, 3 minus 5x. Because it's in parentheses, we say times the quantity, plus 4 equals negative 8. Okay. So distributive property is making sure that we have an organized way of multiplying 2 times everything inside these parentheses, right? So I'm always going to start out with my wall of equality because we love it. And then I'm going to connect this 2 to the 3 with a little arrow. And I'm also going to connect the 2 to the negative 5 with a little arrow. Those are my reminders that I'm going to multiply 2 times 3 and 2 times negative 5x. And that is the distributive property. We're distributing that 2 and multiplying it times both of these terms. And now we're where we were the previous page. What are my like terms? What are the things that I can combine? Grant?
4 and 6.
4 and 6. I'm going to put little boxes around these since they don't have variables. So what is 6 plus 4? So I've got 10 minus 10x equals negative 8. And now I have a
Variable.
two-stepper. Yep, you're on it. Okay. So this is a 10. It's not negative, so I know it's positive. So I'm going to subtract it for the inverse operation. So now I have negative 10x equals negative 18. And then I divide by the negative 10. And I'm going to have a simplified improper fraction. What's my simplified improper fraction going to be? So what can go into 18 and 10 evenly? 2, right? Okay, so 18 divided by 2 is 9. 10 divided by 2 is 5. And then is my answer going to be positive or negative? It is positive. Why?
Because both the numbers are negative.
Right. A negative divided by a negative is positive. So this is my final answer. Not pretty, but that's the answer. All right, let's try another one. I've got negative 3 times the quantity x minus 2 minus 5x equals negative 9. I'm going to draw my wall of equality. Then I'm going to draw my little arrows as visual reminders of what I'm distributing. So I'm going to have negative 3x plus 6, right? Because a negative 3 times a negative 2 gives me a positive 6 minus 5x equals negative 9. Liam, what are my like terms for this equation? Yep, so I'm going to circle those with the negatives so I remember that those are both negative values. So how many x's do I have?
2.
Woo,
8.
getting closer. Negative 8, right? Because a negative 3 minus 5 is going to give me negative 8x plus 6 equals negative 9. Now I've got my two-stepper, so I'm going to subtract my 6 from both sides. And I'm left with negative 8x equals negative 15. Divide both sides by negative 8. X equals positive 15 over 8. I can't simplify that any further. We're not going to do decimals and we're not going to do mixed numbers. We're going to leave it like that. Okay, last example. negative times the quantity 6x plus 2 equals 16. That looks weird, so we're going to talk about it.
Ooh, I get it.
What do you get?
That, like, you would have to put negative times 6
Mm-hmm.
x and negative times.
Right. So if you look really closely here, and I'm just going to, there's a secret little 1 hiding behind that negative. You can see it now, right? Because I wrote it in there. Okay, if you ever see a negative in front of a parentheses, you have to remind yourself that there's that secret little -1 hiding right here. So what you just described, Kyson, is exactly what we're going to do. We're going to multiply -1 times 6 and -1 times +2. Let me get my wall of equality here. So I'm actually going to have -6x minus 2 equals 16. Okay, so it changes everything to the opposite values. I'm going to add 2 to both sides. -6x equals 18. Divide by -6. X equals -3. How do we feel about this? 2 thumbs up? Yes. Do you have a question, Kyson?
No.
No, just you feel great about it? I'm glad. Okay. So your practice that you're going to start today and finish tomorrow is combining like terms and distributive property. So let me get that passed out to you.